All right. All right. Welcome to All Things AWS. Uh, Mostly trying to iron out what I feel is a good talk. Still not quite pleased with it, but I think I've got at least a working draft. So run through it. As always, would love some feedback. Let's jump into it. Looking at AWS, which kind of runs not the majority of the internet, but coupled with the other large cloud vendors, is really what drives the internet as we know it today. Do I have slides? Yay! Not going to introduce myself to this group, just going to point out I finally, after 12 years, decided I needed a new photograph of myself. So jumping way back, obviously, Amazon was started by Jeff Bezos in the early 90s. He's often like, he is a brilliant entrepreneur, but it's interesting. I always anecdotally thought that he was really into selling books or really had something already in works that the internet helped him kind of accelerate forward to the giant company it is today. Wasn't really the case. In 94, he was working for a hedge fund, so very much trying to track market trends and see what was going on. Was not a huge breakthrough to see that the internet was the hot new fab in the early 90s. And during a later interview, he shared that through his research, found that internet was growing off the charts. Again, not overly profound, but he took that and decided he wanted to capitalize on that growth and enter into that space. And that was the genesis of the thought that was Amazon. When looking for the advantages, the intrinsic advantages the internet would bring over traditional companies at the time, he really honed in on the idea of mail order catalogs, just from like a cost analysis. It's a lot easier to maintain giant catalogs of endless products if you don't have to collate that, put it in an actual printed document and mail that out to people's houses. So immediately he was thinking, that's a good space to get in. We can compete on that and dramatically reduce costs, and kind of build up a competitive advantage based off of pricing. So in 95, Amazon launches from a garage, because I think all good technology stories are required to launch from someone's garage. And he started selling books. Again, the idea was he wanted to get on this internet bandwagon, wanted to start selling something. Books was a really interesting idea, from thinking about the logistics that go into storing in a warehouse. And again, running out of the garage, it was early on pretty small shelves and such, but they quickly expanded out to buy a warehouse. Books are unique in that they're really easy to stack up and catalog and kind of store just based on their physical shape and size. Additionally, the amount of books in circulation in print is kind of vast. And again, he was able to lean into that competitive advantage of, I have an online catalog. I don't need to worry about printing giant tomes worth of all of our inventory and mailing those out to our customers. Everything's online. People can access what they want and can buy whatever it is they need. And it kind of just started as an online mail service. A few years later, they eventually went on, got listed on the NASDAQ at $18 a share, and started to grow through the dot-com bubble era. Kind of unique. Again, they weren't the only ones. There were a lot of people entering the space. A lot of people just entered the space on name and hype alone. That's kind of what led to the dot-com bubble, with a lot of overvaluation. What put Amazon in a bit of a unique position is they did have some revenue, but this was, again, hearkening to some of Jeff Bezos's brilliance in the 90s, was very much on the idea of investing in the future. And I think it was in 98 in a shareholders meeting, he laid out his vision for this 10 and 15-year goal that he saw the company achieving, and was pretty forthright that he was okay, basically breaking even or even losing money years to come to achieve that. The idea of not making money was not unpopular at the time, but having some revenue and the long-term vision beyond just as a CEO, like the quarter-to-quarter or year-to-year results, was a perfect combination that was able to let them weather the storm that was the dot-com bubble, survive just enough to see that plan kind of into fruition. So obviously, Amazon very quickly saw success with selling books, expanded into more products, and started this idea of, we need to start selling more products and more products. And the idea was, we were just an online store. Kind of their big innovations on, or what catapulted them even further as far as being the dominant storefront we see today, was they started this idea of the Prime membership, where you could just pay a yearly subscription fee and it would give you free shipping, but you locked the people into your ecosystem at that point. They also started integrating with other third-party sellers, so they weren't having to manage all of the logistics of acquiring the products and doing inventory and holding on to products and things like that. It really started to see a transformation from Amazon as an online store to Amazon as a platform. And I think this is starting to build an interesting pattern just from looking at the high level of the business perspective. If you have someone that just wanted to get on a growing trend, did so in a very efficient manner by attacking books with kind of the unique opportunity that would present him with the advantage of the catalog and storage and sorting and shipping. And then, recognizing that inviting other sellers to your online store and kind of becoming a platform was a great way to innovate and kind of capture more market share within this space. And I think this kind of idea of innovating and constantly looking out in the long-term horizon and moving into that space and figuring out how to take advantage of the situations really is at the heart of Amazon, especially in the early days, where it was mostly, I would say most of their success seems to be driven around innovation. Again, in recent years, it seems to be a little more contentious with where some of their profits come from and how much their growth is based on that versus innovation. But in the early days, it was very heavily focused on this long-term vision of figuring out how to dominate the space. Being that in the early 90s, there weren't very many large operational online stores, not only investing in the business sense and figuring out how to grow and offer more products and figure out the logistics of the free shipping with the membership, Amazon was very early interested in innovating to support this online ecosystem that they were building out. This is kind of still in the era of data centers and having a lot of IBM mainframes. So they started their Amazon, well, it wasn't the cloud computing industry yet, but they started their own computing process. I cannot remember the gentleman's name, but he was just recently announced to be Bezos's replacement. The gentleman that's run the AWS portion of the business for the last 15 or 16 years. Anyway, in 2004, they have a really robust operations team, some great that's it. They have great software. And they really recognize that they've solved industry-wide problems that probably are applicable for more folks than just those running the online store, them and other Amazon teams. So they look to start offering these services out to other companies as kind of a bespoke software as a service. The first one was launched in November 2004. That was the Amazon Simple Queue service, which is just a hosted queue service. So you can, it was great for tracking orders and managing cart flows and things like that. I think the first one really only supported like the first in, first out operations, but they did that, launched that, saw some mixed success among the enterprise community, saw a lot of interest, and started looking at white labeling some of their other services, and that's what really drove the moving into this new space. In 2006, they launched their simple storage service, which was S3. That was their hosted storage solution available through their data centers at a cheap cost. Most of the cost advantages from there came at their size. Even at that time, they kind of were starting to benefit from the economies of scale and were able to offer storage solutions at much less, and had already figured out how to scale that up to fit their own personal needs. So they had solved a lot of the problems other enterprise clients would run into with trying to scale that up to be on a similar level. The other big tool that they launched was the Elastic Compute Cloud, or EC2, which is the virtualized Amazon servers running again in their data center. And this kind of was the forefront of this. They took the world a bit by storm, and they're looking at a 2 to 4 year like first movers advantage into this space. I think the other big tech companies that were prominent still at the time are, of course, Microsoft. Oracle was still kind of enjoying a lot of the success out of the 90s. IBM hadn't really fallen out of favor yet, with decades of failing to innovate on anything new. And you had a mixed reaction from their peers. Google, also being a bit of an innovative internet company, kind of had a panic moment of, this is brilliant, and the fact that we're seeing these services in 2006 as finished products is terrifying. We need to catch up. This is definitely the future, which is good on them. They got a bit of a late start. Some of the other ones, Oracle, not really worried about it. Amazon, Microsoft was content with their legacy systems of running out, licensing out Windows servers, and kind of assuming that on-premises solutions and the data centers would be the wave into the future. So Oracle and Microsoft largely just kind of ignored it. IBM wasn't in a position where they were looking to innovate either. They were really doubling down on their business model of getting you on their hardware, getting their hardware installed in your on-premise solution, and locking you into an ecosystem that is a nightmare and miserable to leave. That was kind of their long-term strategy through the early 2000s, well, and today. You started seeing other cloud vendors move into the space. In 2004, you've got AWS pilot program where they start taking on other clients to use some of their services that we listed a little earlier. In March in 2006 is when they offered the first beta of the EC2 program, where you could get on and spin up their virtualized compute instances. In the early days, they were only running Linux operating systems within the EC2 clusters. In 2008, again, Google, a little bit panicked, tries to show up to this party just a little bit late, but they launched their Google App Engine pilot program, which is met with some mixed success, but they're launching it on the heels of AWS deciding that we're comfortable enough with this, we're going to start offering SLAs out. We're comfortable enough with our product stack, and refined it enough in the public space that we're going to start issue those service level agreements, which is kind of the last barrier to get those enterprise tier clients that they were looking for. Finally, at this point, Oracle, Microsoft start to have the panic moment and are seeing the writing on the wall a few years late, but trying to pivot and move into it as well. Again, for comparison, AWS pilot in 2004, all the way 6 years later in 2010, finally, Microsoft shows up to the party. They launched their Azure instances, which is their virtualized competitor to EC2. In May 2010, Google launches the Google Cloud Storage, which is their competing product with S3, which is their, it's hosted in the cloud now. And all the way in 2014, Oracle decides they want to try to launch Oracle Cloud. To kind of minor success at best. I would say at this point, they're showing up 10 years late. They're already at a competitive disadvantage, and a lot of their market share exists today still from just their clients that are kind of stuck into the Oracle ecosystem. And there's an interesting chart just kind of looking at the adoption and speaks to kind of the success early on that Amazon saw with their S3, SQS. It was fairly well received in the engineering and development communities. Again, these were solving common problems at the time. Through the early aughts is when we started seeing like, hey, storage is cheap and you can rely on cloud-based storage within data centers where they benefit from economies of scale and can quickly provision up and down to fit your needs. And you saw people like Dropbox come in and some others start to really leverage on top of this idea and pivot and build on top of what some of the large cloud providers were offering as far as infrastructure. So it's a little bit dated, but this kind of speaks for how much that early innovation and first mover advantage played into AWS's favor. Just looking at overall internet traffic as far as what major web services are built with and what traffic flows through, AWS has about 41% market share of all of the cloud computing traffic that's hosted out there in public. This does exclude the private clouds contracts that Microsoft and AWS has with the US government, but this is at least what's on the public sector. Microsoft Azure kind of being the other big player, which I think makes sense. A lot of AWS, especially in the early days, was all pivoted around Linux. It wasn't until much later that they started offering various Windows offerings. Windows was able to, or Microsoft was able to move into the Windows space within the cloud a little bit easier, and things like Office 365 hosted Active Directory through Azure. I think gave them, it was an easier option to go with Microsoft. But everybody else kind of, at least in 2008, kind of shrunk down into their small little market segments. It's interesting to think that Amazon really was at one point almost 50% of all of the cloud processing that we had out there. Try to break it down a little bit further. These were accurate numbers as of, I think, November of 2020. I should have put that as a little footnote here. Breaking down, looking at just infrastructure as a service, which is more of kind of the bare bones where you're configuring networking and not so much worried about a finished product. Comparing that to like the infrastructure and platform as a service solutions with a little bit more polished things on top of it, like AWS's Elastic Solar, which is not them hosting open solar, it's their fork of solar that's all pre-configured out of the box that you kind of don't have to worry about using anything within that. But even looking at the two, like they still have such a strong market share as recent as November of last year. And you can kind of see others. Interesting enough, Alibaba has been creeping up past Google and IBM, and there are some smaller numbers with Oracle and some other players, but it's really AWS, Microsoft, Alibaba, and Google's game at this point. So the cloud, looking at the specifics and kind of the impact it has on us as developers, it's often described to me in various instances with either other developers or especially with some of our marketing and sales team that it's this ethereal option that just kind of solves all of our problems magically, which would be great if true. As far as AWS's cloud offerings, and to be honest, this is a bit dated. It's just I can't get a screenshot to fit all of the services that they offer. They are vast and many. Some of them are a little bit more niche. Some of them are pretty general. We can see if we look over in the top left corner, there's our EC2 instance. Under storage, we can see S3. They've kind of expanded out. And at this point, it's not that they haven't solved every problem, but they've solved a lot of the problems that we run into with building infrastructure out to support various application needs. And various scaling issues that you'll run into. They've kind of solved them in a handful of ways, and really it's on the people implementing it with finding a solution that works best for you. So instead of going too far into kind of the ethos and some of what drives it, I want to look at one of their services right off the bat. It's called AWS Lightsail, and it's designed to be a extremely managed, extremely on the rail experience for hosting or launching a server instance. So, and in fact, it's a little bit friendlier than I would say the typical AWS experience. It has its own little own self-contained console. It's a little bit more user-friendly. When you first go there, you're greeted with this nice little cute robot that waves to you and says, like, let's get started, come on. So I'm going to walk through what that looks like. At this point, I'm going to run everything through the AWS Management Console through the GUI. Anything that you can do through their online GUI, you can also do through the AWS CLI console, or it's mostly true you can also do it through any of the SDKs, and they provide an SDK for effectively every language. For all intents and purposes, it's everything. There are very few edge cases where some SDKs aren't fully supported. So you can see there are a lot of services here. Typically, when I'm looking for a specific service, it does try to help you out and go like, hey, here are some recent services you've used. If I'm looking for a specific service, it's much easier just to search for it. They used to have an option to filter alphabetically if you didn't want them grouped by the service type, organized like that. But I think they've removed that as they've added more services over the last few years. So you can see now that I'm in Lightsail, I have this previous instance of Lightsail server running. I'm going to ignore that for the time being, and I just want to create a new instance. As far as creating a new instance, it does ask me for some input. This feels, it's a managed hosting experience where they're doing all the heavy lifting of the infrastructure for me. It really feels similar to something like Rackspace or even Linode, kind of back in the day, but you can see I can choose. At this point, it's, I want to say I started offering Windows Lightsails last year, but first I can select my operating system that I want. In this case, I want Linux. Scrolling down to the next section, they've got some pre-built blueprints out that support several major applications. If I wanted to, there's one for Drupal. I could spin that up and it would make sure I had all of the appropriate resources and had a LAMP stack along with the database server, and would go ahead and drop a starting instance of Drupal 9 for me. Alternatively, if I just wanted to pick an operating system, I can do so. Again, I would say Linux is definitely more supported kind of across the board. Windows is an option. I think for Lightsail, it's just Windows Server. There are different and better services if you were looking for Windows specific use cases, but for the time being, just going to stick with Linux, and let's spin up a new Ubuntu server. If I wanted to add a launch script, that's just kind of the first script that would run when the server started up. If I wanted to preset some things or pull in some environment variables or something like that. If I wanted to add an SSH key directly using like giving it my private SSH key, I could, and it would go ahead and configure that for me. Yeah, $40. So as far as pricing, it's kind of on the rails, and if you're looking at just spinning up a cheap server instance that would handle a small site, honestly, I think $3.50 isn't a horrible price to shake a stick at. It would handle, I don't know that it would put a large traffic site on it, but at 512 megabytes of memory, you get a single core GPU, which is fine, 20 gigs of SSD, and we get a terabyte of file storage. I can live with that. They do have several other pre-configured options. If you were looking for something more specific, like if you wanted to host an application that you knew was going to be very memory intensive, you could go that route and kind of try to get something that's a little more dialed in on memory. The same is true for CPU storage, or if you wanted to have a lot of bandwidth, you could do that as well. Finally, I'm going to identify my instance, which is just a label that I'm applying to this instance so that I can find it later. Give it Doug. Additionally, you see the numeric input there. If I wanted to create multiple instances of this, I could, and could even do something like this site's really important and I can't handle any downtime if for some reason this instance went away or something happened. If I wanted to have multiple to handle traffic spikes, or just in case one of the two virtual instances went away, could do that all from here. For now, I'm just going to delete it, click create. It'll do its thing. it's launching it. Should be fairly quick, but while that's running, I'm going to go ahead and click this and ask so it popped up a new window. Is everyone able to see that window, or is that outside of what's being shared?
It's outside of what was shared, I think.
Yeah, we're not seeing the window.
That tracks. Don't think this will work, but let's see. Okay, there we go. So all I did here is, if you don't even want to handle connecting to it, and you could do this again directly through SSH, could do it through the AWS CLI, which would 100% be the preferred method. We'll talk a little bit about that in a minute. But if you just want to drop straight in, they've got their GUI-based terminal that you can just SSH directly in, which I've done here. I can go ahead and run any commands I could run on. I wanted to run on Linux. I wanted to install Steam Locomotion to remind myself that it's LS, not SL, and sit through this painful animation every time. I could do so. Oh, can't cancel out of it. That's right. But as far as we're concerned, we have 100% live virtual instance. So you can see in the time that I've been talking, my Ubuntu box that I just set up is created, and it really likes to pop those out into a new window. Let me drop into a terminal. So at this point, I have my bare bones Linux box set up. Could run through, and if I wanted to, could install all my source repos or update all my source repos and do things like install Apache and run through the entire setup that I wanted. Since I chose just to get the operating system, nothing's there for me, so it's entirely up to me. Do I want Apache Nginx? What configuration do I want? What version of PHP do I want to install? It's really just your vanilla Ubuntu operating system at that point, which is great. Looking at this, we can kind of see a couple options. This is more of your actual instance dashboard, can start and stop it. What's nice, it's so managed on the rails. I didn't have to set up any of the networking. I already have a public IP, which is accessible if you go to it. It went ahead and attached, well, no, I didn't attach storage to this, but I could attach storage to this if I wanted to and mount block storage. If I wanted to, I could see the metrics of it, the networking, could even take snapshots of it if this was something I wanted to like create an image for and spin up other instances off of. Even like if you've ever used IP firewalls before, like could set some of those up here. Again, it's really basis out of the box. We don't have any, I'd say it's kind of flippant with some of the security that it gives you out of the box with Lightsail. You can see it accepts port 22 is just open, and hope no one abuses that. But in this case, this is the IP address. Just wanted to share nothing special, not even a PHP application, just my slides from a previous slide deck where Kaylin and I talked about Locus.io. But if you're looking to sandbox something or wanted a lightweight hosting option for a Drupal site, or even a development server, which I think is another great use case for these, very easy to spin up, and AWS kind of handles all of the more complex stuff for you. All right, demo 1 successful. So I did want to briefly kind of chat about infrastructure as a service versus platform as a service, and finally software as a service. Infrastructure is more, if you're thinking of the OSI model stack of networking, it's really further down on the bare bones, where infrastructure is going to handle the hardware requirements for you, and some of the virtualization requirements for you. So we don't need to worry about installing anything in a data center. We don't need to worry about networking between the data centers or anything like that. We're going to just, Amazon's going to handle, or really any infrastructure provider is going to handle all of that virtualization layer for you, and you can just drop things on top of that. through any of their options they give you. Sometimes it's Docker, sometimes it's each major vendor has their own kind of either cloud compute or similar alternative to that. That's really for the people that want to have more granular control and you need to have fine-tuned specifics. Platform as a service is more where your vendor will handle, on top of doing all of the cloud virtualization layers, they'll also handle managing the operating systems for you and any runtimes for you that you need. This is things like, and you'll find this with a lot of AWS services. I have, if you saw on Lightsail, I had an Ubuntu server I spun up because it is a managed service, and that definitely falls more into the platform as a service. AWS will handle patching that for me and doing all of that for me. It'll also handle some things like what happens with recoverability if the instance goes away. How do I scale up if I have traffic spikes or anything along that? It kind of pushes the responsibility of that off onto the vendor. And finally, you have your SaaS products, which are more kind of like your Trello or your Jira's. They handle everything within the entire application stack for you. The big benefits, and Amazon, we've seen this a lot at Mindgrub, and I think Amazon harps on this a lot for what their benefits are. And again, it's true for all cloud providers. You're trading like large guaranteed capital expenditures for a variable expense. The idea that they try to perpetuate throughout is really dial in and find solutions that work for you. Only pay for what you need, only pay for what you use. Going through any of these vendors, you do to some extent get some benefits from economies of scale. You're going to have a hard time competing with Amazon. Like if Will and I were to go out and try to spin up a data center, we'd have a hard time getting similar prices for what Amazon pays to build one of their data centers or acquire hardware, even like electrical rates for it. It's really tough to compete. And while part of that goes back into Amazon's profitability, some of that does trickle down to its vendor clients, which is a benefit for us. Of course, you'll see an increased speed and agility with being able to switch and find solutions and jump from one solution to another or scale up. And the idea is, especially for large organizations, the idea is to stop spending the dedicated money on managing your own data centers or managing on-premise solutions. I don't know if anyone's had the opportunity to work at an on-premise or at least go through an on-premise solutions. They're beautiful facilities. They have to have their own HVAC and air filters, and you have to have usually like reinforced floors, and they've got the tiles that you can lift up for cable conduits, and it's a lot of work. And the idea is there's other things that you can focus on. Don't worry about that. Let Amazon handle all of that for you. And the other big option is because of their scale, this is also true for Microsoft and Google, you're really able to scale out globally kind of at a moment's notice. If a project we're working on, an application decides that we really need to be available in Australia, it's at least from operating off the East or West Coast, as far as infrastructure is concerned, it's extremely difficult to deliver a performant experience hopping back and forth between a US server and going into Australia. They have kind of their countrywide firewall, and it's been a problematic. So, and if that was a desire you had, or really at this point anywhere globally, you could federate and create multiple solutions based on different regional requirements. I touched on this a little bit earlier, but along with kind of thinking of Amazon solutions as infrastructure as a service or platform as a service, they also, for almost every solution they offer, they'll tend to offer a managed and an unmanaged solution. The managed is usually something that is pre-tuned out of the box that they'll handle for you. Again, the idea is reduce costs by only paying for what you need. And it's kind of similar to the idea of the like free and open source of you are paying for it, but you're not having to maintain someone on staff all the time to constantly keep an eye on all possible security threats that come out for Ubuntu or any other operating system. if Amazon, who is very good at that, is on top of that, they can monitor for things like that and be much more vigilant with it than a smaller team could. And it's just kind of pushing that responsibility off at a cost. So light sale is great for just getting things spun up pretty quick. But if we decide we want to build something that's not as on the rails, which is basically every other AWS service, it's not unlike Drupal in that it's kind of like handing you all of the tools in the world to build the tools that you need to build the application you eventually want. There are a million ways to do it. There are probably 900,000 ways to do it wrong. And I think it's a little bit more impactful when you're looking at the infrastructure level. Poorly architected infrastructure could lead to huge scalability issues, or more prominent, huge security issues. Luckily, to guide us through that, Amazon has published what they call the well-architected framework, which I've linked to in my slides, and I'll share them out after this. But basically, that white paper breaks it down into there are 5 main pillars to building any kind of infrastructure out. You need security, reliability, performance, efficiency. We want to make sure that we can scale correctly and as we need. Cost optimization. We don't want to scale out to infinity if we don't need the resources. Again, the idea is only really pay for what we need and what we use. And the lastly is just operational excellence. We really want to be able to meet any of the challenges our application might incur. Security is kind of the big one. I do want to talk about this for a second. The idea is to apply security to all layers. It's the idea of, they really emphasize the idea of least privilege. Again, because it's infrastructure, there is nothing that would stop you from building out infrastructure and adding a private SSH key in, or adding your own root user in with the password of admin. You can do that. They try to kind of help handhold you through and have very granular security tiers through group users as well as network permissions. And you can, not going to dive so much into them in this presentation, but you really can do your due diligence to ensure you're hardening your infrastructure from any kind of less than ideal point of entry. And I always think back to that admin account that was left on some production running instance. You can kind of completely negate that with some of the security group and network policies that they provide. And the idea, they do kind of emphasize the idea of automating this as much as possible. With how I've seen AWS implemented some places, we can't SSH directly into any production instances. We have what's called a Bastion server, which acts basically as a gateway, and we tie that up to an Active Directory. So Amazon can say, can always see who is this, who are the active employees that should have access, that's updated in real time. Somebody is no longer an active employee, they get removed from the pool. Every time you try to SSH in or go through the SSH tunnel, it spins up a new instance of that, which pulls in a fresh security group, which kind of just at least reduces one attack vector of people remaining and keeping access to things that they shouldn't once they no longer work at a particular company. Reliability, this should go without saying, but we should be testing our recovery procedures. You can email backups if you want. I think Amazon offers a little bit more robust solutions. Ultimately, the idea is that your servers or your application containers, whichever you're running, they're not your dog. They're not your pet. You shouldn't have pet servers. I think the analogy I've heard a lot is your server instances should be more like cattle, or maybe a head of cabbage. We should be able to have those things go away and not have any emotional attachment to it. If my dog went away, I'd feel very emotional and sad about it. If my server went away, I shouldn't care. There should be recovery processes in to spin that back up in the correct state that it was. and I shouldn't be able to really even notice it. There may be downtime depending on what the circumstance is, but for the most part, there should be recovery processes in place. And I think you'll see through a lot of Amazon processes and services, their SLAs vary. And I think it's interesting to think about. Lightsail, for example, I think has a 99.9% reliability uptime guarantee, which is great. It means most of the time you'll be fine. And frankly, anytime I've talked to a client about this, they almost always are also fine with the 99.9%. But that does mean you'll, on average, throughout the year, have several hours of downtime. And despite being fine with that when we were going through contracting and provisioning out resources, that never stops the clients from angrily calling me anyway. But just keep that in mind. And I think that's kind of needs to weigh into some of the decisions when you're looking for a particular solution, is what the reliability of that is. Performance efficiency, we talked about this a little bit earlier. We can go global at a moment's notice. For the most part, there are some asterisks, but as long as we are adhering to a well-architected principles, we should be able to scale out and make those resources available without too much added effort. It also means we can, because if we're thinking about our server instances as, I see Aaron linked the high availability percentage calculations. Because we're thinking of our server instances as something that can go away, we also have a lot of metrics and backups with it. It does give us the ability to experiment often, and we can make incremental changes and kind of monitor the differences. And it's not a big deal if we want to quickly change out, say, a version of PHP to a new major release and see the impact it has. Because it's running on our server, if it's not what we like, or we realize it's catastrophic failure when we launch it in production, we very quickly can just destroy that server and roll back to something a little bit more nuanced. Cost optimization, I mean, I've talked about this a lot. It's, again, paying for what you use. The nice thing about once you are using any cloud solution, more often than not, you'll have really robust metrics associated with that, which will boil down ultimately to a utilization chart. So you can see, how much of this resource are you needing? And I think that gives you the data to have the conversations around, is that a resource that we need? Can we switch to something that's a little more ethereal and can go away and be called at a moment's notice? Or do we really need to have 6 instances of the server up at all times that never get used? And of course, operational excellence, which I'll skip over here for the sake of time. So looking at our 5 pillars there, looking at AWS, as far as looking from a security perspective, it's kind of okay. Port 22 is open on that IP address, so that's less than ideal. That's not really adhering to, we want the least privilege possible to have access to that. Reliability, it's okay. Again, I think it's at 99.9, but I'm also running a single instance. So if that instance were to go away for any reason before it could come back, that would mean my application is down. There's no real performance efficiencies or cost optimizations that come into play there. That is, I have provisioned that server, it's going to remain mine, and it's always going to be available whether I'm using it or not. So I'm not seeing any kind of cost optimizations or anything like that. And there's no real optimization excellence there either. I'm not really able to make any kind of small iterations to it. In fact, I think the most I can do is scale that up 1 tier above from what it is. Interestingly enough, Amazon will happily let me pay them more to scale up, but I don't think they, as of today, have a way to scale it back down at all. There are ways to get around that with Lightsail, but let's move on from Lightsail and look at something that's a little bit less on the rails in Elastic Beanstalk. As an aside, Amazon's icons are extremely baffling to me. I don't know how this relates to the Beanstalk, especially with how similar this is to some of the other Amazon service icons, but this is the Beanstalk icon, which looks very similar to some of their network service icons as well. I mean, you can, but how is it different from the green one that's just the inverted of the Beanstalk? Okay. Elastic Beanstalk is easy to use, Amazon's words for deploying and scaling applications. And currently, as of now, it supports most major web languages: Java, .NET, Python, Ruby, Go, and of course, PHP, which is particularly useful to us as Drupal engineers. It gives you a little bit more nuance as far as what you want in your application stack, Apache Nginx, ISS. It starts to also make available some additional AWS features like load balancing, auto scaling, things of this nature, which are great for scaling performance horizontally, or we can also scale vertically depending on how we configure that. AWS is no additional cost for the resources that it provisions for you. It's just a nice kind of managed way to orchestrate all of that for you. The nice thing is the resources that it does spin up and provision based on what you configure it to, that's all you pay for. So I don't, if I know I can spin down and I only need to have one web server to keep the site active, but I want to spin up to multiple during a traffic spike, I can do that and configure it to spin those back down when traffic subsides. Maybe in the evenings or the weekends, we can go down to kind of a bare minimum. Handles capacity provision, which is great. Also handles health monitoring, so we'll make sure that my applications are healthy, that nothing's gone away. If it does go away for any reason, like if Apache stops running or PHP gets overwhelmed, it is smart enough to kill that instance and restart a new one. There's a great article, which I've linked here in the slides. Again, I'll share these after, to an article on specifically spinning up a high availability Drupal site on Beanstalk. So when thinking about a Drupal site specifically, beyond just having a server instance, typically we want to have some kind of solution for files. We don't want our site's files, thinking of like our site's, our public file directory or private file directory, we don't want those to be attached to our server instance, because if that goes away, which we want it to be able to, we don't want to lose all of the files with it. Enter Amazon's network storage, which they call Elastic File System. You'll see this referred to as EFS. I think the going trend is basically with every Amazon web service, it tries to get boiled down to just a 3-letter acronym. Elastic File System is EFS. It's really similar to any kind of network file share. You can think of it similar to an NFS mount or Samba in Windows. It's no different. It's network files that gets attached to the instance. In the case of installing Drupal, this would be where we would write all of our public and private files to, or any kind of files we wanted to persist beyond the lifecycle of the server instance. Again, it's kind of nice. It's a pay for what you use solution. I don't need to decide upfront that this Drupal site that is going to allow users to upload recipes needs to have 20 gigs of memory and pay for 20 gigs of storage in perpetuity. It will just add, it'll scale up based on how much I have in storage. In fact, I think it came out last year. There's a feature called Lifecycle, where it's, again, a bit of a managed service. It's something you can just, a little checkbox you can click when creating file shares or file services within AWS. But basically, if you have any file within your file system that doesn't get accessed over a 30-day period, it will move it into what's intended to be a little bit longer term storage solution. And in doing so, will reduce the amount of cost. So the long-term storage solution costs slightly less than the standard storage solution, or actually significantly less. But there is a bit of a trade-off. If you're okay with that, it does increase the time it takes to access those files. So if I, again, thinking of a recipe site like Umami, if I upload a file and no one accesses it and doesn't get touched for a month, it'll move over there. It's cheaper to store. And I think the SLA on standard storage is 1 to 9 milliseconds, and I think it doubles for accessing infrequent storage. But what's interesting is just to note with the cheaper storage cost, you do pay a cost for moving things out of the long-term storage back into standard storage. Once it's accessed, it does leave and go back into the standard storage bucket. The third main pillar that we need in our Drupal sites, we've got our web server that Elastic Beanstalk has spun up. We've got our file system. Lastly, we need a database. That's where we look at AWS's relational database service, keeping with the trend. This is typically referred to as RDS. It's like most of the cloud services, cost efficient in that it's resizable and you can kind of scale it to fit your needs. It's yet another solution that is pay for what you use. As far as the variants that they offer, they are all relational database services. So things like Redis or MongoDB wouldn't be included in this, but they support MySQL, MariaDB, not listed here, but MSQL as well, and most other popular relational database services. And Aurora. Aurora is Amazon's highly optimized fork of MySQL. It typically pushes most people towards that. It's already pre-configured and highly optimized and works well with running a database within the cloud. As far as RDS, the way you can install it, it comes with two main varieties. Serverless is a bit new. I have typically always preferred to stick with provision, mostly because anytime that we deviate outside of relying on Pantheon or Acquia, which solves all of this for us, we typically have specific needs and don't want to deal with anything other than a provisioned. But serverless is kind of nice. It will effectively spin down when you're not using it. And the next time the application spins up and makes a request to your database, it will reload the database server. And it's, in terms of spinning up a new server, it's quick, but you do have some application downtime while that new server, that service spins itself back up. And if you've ever used, I don't know if Acquia does it, but I know Pantheon does it a lot. If you ever leave one of their dev or test, or even the multi-dev environments alone for, I think it's 12, maybe 24 hours, they deallocate all of your resources and you have to access it, receive a 504 error, wait, and then access it again once all of the stuff on there and has spun up. I don't think they're using this, but I think they're using something very similar that basically just recaptures all of their provisions and doesn't allocate any resources to it unless it's being called for and it's actually needed. With that, it's great. It will, being serverless, that we don't have to have something hard provisioned. This will scale a lot better, and that we can just spin up a new serverless instance that can scale with our disk, our CPU, our memory, and kind of just is a lot more responsive as far as what we need. Alternatively, I think we've used this for a couple applications where we didn't need we basically needed a secondary storage engine, but we didn't need it to be 100% persistent all the time. We basically wrote something we could throw an image in a queue, and we would have to throw it off, do some processing, get the result, derive some information from the process result, throw it in a database, and then give an API response back that we were done, which was a great use for serverless. We didn't need to have a storage solution on demand all the time. It does usually start within sub 30 seconds, but if I'm a user, that's frustrating having to wait that 30 seconds. Okay. So going to look at, let me close out my tabs. Oop, went too far. There we go. Get out of the light sail, kind of pretty in the box dashboard that they have. So next, I'm going to look at Elastic Beanstalk. See here, I already have, I created an instance a little bit earlier today. So I'm going to go ahead and create a new environment. Nope, I want a new application. Creating a new environment is similar to what Pantheon and Alchemy have. If you wanted to run an application, then you could create like a dev and test for that as well. Okay, so I'm going to create a new application. You can see it's interesting once I get pulled out of the fully managed non-customizable experience, the dashboard kind of reverts back to something that was definitely built by engineers. Now for Doug, let's go ahead and create. Let's create one now. I don't want to create a domain. Okay, so I'm going to choose a platform. Options are kind of similar, but this is going to provision what kind of instance it gives me. The big ones that I can run are Go, Java, Node, PHP, Python, Ruby. There are some others. Again, I think there are better solutions for running .NET within AWS, but they're here if you want. There's also a Docker instance. I think there are better ways to run Docker within AWS as well. But for the time being, I'm just going to run PHP. Cool. You can start with an existing application. Again, since Elastic Beanstalk will handle both, will handle provisioning out our server instance as well as our file storage and our database. It'll also allow me to publish my application to those instances. I think it's easier to start out with a sample application and then package up and deploy your application after the fact. So as that's walking through, it doesn't take a long time, but I'm going to briefly switch over to the one that I pre-provisioned before this, which is erroring. Unfortunately, my live demo is stopped here, and that I don't have my blocker here is I just don't have an IP address to allocate some new networking to support a new file share. So I cannot upload a new application, which is what I was doing earlier this afternoon. But to walk through kind of what that process would look like, this, I don't know why breaks my brain, and it's not too dissimilar from how we use Pantheon, but I'm not using Git to push code up to these instances. To deploy to AWS, it's really hitting on the idea of your application. You should be able to produce a production-like artifact of your application. So what we do for this is, if you think of the code for a standard Drupal site, instead of doing a Git push or like pulling down a default branch or anything like that, you take your application, you build it out in the production state. So you've got your any kind of SAS or SCSS compiled. You've got everything kind of, you've got your production settings, you've got your production service .yaml, you've got everything going, and then you package all that up, and you can either uncompress it, or typically we just make it into a zip file. But then you upload your entire site, and it will deploy that as a production artifact to your application. There are some interesting quirks. It does handle, as far as things like your database settings. It would be a little bit weird or kind of strange maybe to leave your database username and password in your code. it handles those with environment variables. So the settings file that it uses for this will pull those as environment variables. So you don't need to worry about balancing out your keeping track of what your production MySQL username and password are. Oh, calm down. I pushed the button twice. Okay, well, that's going. I do want to briefly look, Elastic Beanstalk does handle provisioning out all of the various things that we need. So instead of looking directly in Elastic Beanstalk, what I'm going to go do is look in RDS. I should have, from the application I created earlier, I should have an RDS instance that Beanstalk has created for me. So just by telling it, hey, I want this application, I should be able to go to my databases, and this is the RDS that it went ahead and provisioned out for me for that application to run with that server. Additionally, I should also see, an EC2 instance, which I definitely do. So this is the demo that I just created. This is the server instance that's running like Apache, PHP, and that sort of thing. Here's the instance I created a little bit earlier. This is our virtualized server that it created for me. Kind of seeing some other stuff here. This is our AWS R&D account where we just kind of throw things out either for demo, or if we have a weird, interesting idea, we'll jump over here and start provisioning things out to see how it works in practice. All right, I'm going to move on, mostly because I know that it will not accept my Drupal application deploy, but we'll clean that up and circle back to that. Okay, so we're looking at Elastic Beanstalk. Let's pretend a world that my live demo worked correctly. But even with that, if I was running Drupal within my newly created server instance, I did have to provision resources for that, which means that I've provisioned capacity, which means I'm effectively kind of having to pay for persistent capacity. The EC2 instance that Elastic Beanstalk spun up isn't going to go away on its own. It's just going to kind of sit there. So, I spun that up originally 2 days ago, and it's been sitting out over the weekend, just occurring costs. If you wanted to go a different route, we could look at AWS Fargate. It's essentially the same idea as Elastic Beanstalk, but instead of relying on compute instances or virtualized servers running, it runs entirely with Docker containers. These are going to be something that can be unprovisioned and can go away, and we can call only when we need, being that our Docker containers, once we have an image to build them off of, can spin up much quickly than having to provision a new virtualized server. And it's similar if anyone's ever worked with VirtualBox or VMware or anything like that. While those are great virtualized technologies, it does take a while for those to spin up and provision and boot up their own kernel and that sort of thing. As I mentioned a second ago, Fargate runs containers without having to manage servers at all. It's the same concept of going through Fargate, kind of manages and orchestrates everything for you. So we can specify, hey, Fargate, we need to run a web server, and it's going to need to have a database and a file store. It will handle all of that for me without me having to worry about, again, like the operating cluster or operating system. Won't have to worry about patching or updating or anything like that. And even hardware failures, which will definitely happen, but that's all pulled away from my management, being that the AWS will handle that for us. It will detect that and just kind of shift us over to other hardware without us really noticing any difference. The advantage I like about Fargate or any kind of really containerization technology is because it's something that is able to scale a little bit better. In the case of AWS, when it comes to a billing, we're only paying for the CPU and memory we actually use. we don't have to kind of spin those up and leave those provisioned resources sitting around collecting billing credits. I talked a little bit about this. This is I talked about this at the very beginning, but this is their core compute virtualization technology, Elastic Compute Cloud, or EC2 as it's known, keeping with the 3-letter number acronym scheme that we go. It's, like most things, built as a pay-as-you-go solution. It is unmanaged. They will go so far as giving you some prepackaged images with operating systems, but this really is akin to any other kind of virtualization technology. You can install an operating system and kind of build things on top of that, export your image, and then build other instances on top of that. Those are referred to as omnis. Well, you made it to the end anyway, bud. That's the end for what I have. Anybody have any questions?
Do you have suggestions for how to help folks walk through, particularly for the pay-as-you-go services, for helping them develop estimates on costs?
Yeah, I don't have that on this management console, but yes, the AWS has some like price calculation tools that you can pick the services that you're using, give it some rough guesstimates for how much capacity you think to build billing estimates. I think that's typically what we'll do is we'll go through their estimation tool and try to create like an upper bound, or not, more of a median line of this is what the expectation is.
And you find those are relatively
yes,
accurate, or at least close enough that there's not weeping and gnashing of teeth.
Yeah, the upper bound, so that typically gives us a median where we can agree upon. The other side of that equation is we will work with the client ideally, we will work with the client to determine what the SLA is, and we'll set an upper bound for how far that will be allowed to scale to put some reasonable limits on it. In practical senses, we've struggled sometimes to really articulate what those SLAs mean, what the uptime SLAs mean to the client. I think one example we had, it was a Drupal 7 site that had 2 tables with, I think one had 8 million rows and the other had 13 million, and there were some poorly optimized joins going on between the two. And the request from the client was, cost is not a matter here. We need to be able to survive our traffic spikes with these poorly optimized queries through the next 2 weeks. Remove the restrictions, scale endlessly. And AWS will likely scale to your needs and happily take all of your money. I think our monthly hosting bill went from, I think it was $350 or $400 a month to they got stuck with like a $12,000 hosting bill that month, which they were happy with. But yeah, typically we'll put some kind of upper bounds on how far we want things to scale.
Mauricio is picturing going to his boss with a $12,000 bill.
It can get out of hand. I mean, I think it's within the management console, they do have I think it's just called Calculator, that we found to work pretty well. I find some of their pricing solutions really interesting. I think it seems like they try to accommodate both tiers of the economy pretty well, of people that are trying to be budget conscious and want to be frugal and make what they have stretch, and people that are here's a blank check, make it work. To that, I think I can't remember the name of the service, but they have their own supercomputers that if you wanted and were capable of, you could run like the universe simulations on that are typically reserved for like Nike and all of the enterprise clients that go at a premium because they'll reserve, hey, I want 30%. I want to be able to use 30% of the server for the month. But they have a price conscious of, if there is any available downtime, we will squeeze you in between our enterprise clients using it at a huge discount. But if they do show up and they need it, we have to boot you out.
The high performance computing solutions, yeah. I'm trying to remember what they call them.
It is fun thinking about kind of beyond Drupal. If doing a lot of larger application development, I think they have a lot of really cool tools from a development perspective. And it's not unique to Amazon, but just the fact if you wanted to do some kind of machine learning or voice recognition, or even, I know earlier this year, we scoped out effectively rewriting call center software. And we're looking at trying to build out that layer that intercepts in the machines, like the computers that ask you for like, hey, what are you asking for? And then we'll translate that down and try to route you appropriately and determine how angry you really are and how quickly you really need to speak to a person. All of like integrating with call services, Amazon Lex, their like voice recognition that they use on Alexas, all of that's available through AWS.
Yeah, I gave a talk for best students on some of the challenges in AI and in big data processing, and why not to necessarily trust them it just because it comes from a machine. But one of the things we were talking about was how low the bar has gotten on doing the learning side. That, Amazon is, the SageMaker stuff is pretty cheap. Hard to use a bit, but cheap and way easier than it once was. And, has gone from being specialized, dedicated hardware to a service you can buy for 3 cents an hour from Amazon.
Yeah, no, it's interesting. I think I'm going to pause the recording there, or stop it rather.
Yeah, go ahead and stop it.